so yesterday, okay, just to review a little bit, okay, you learned about, on page 1 of your handout, right, we learned about power functions, what they are. And the three that I recommend that you familiarize yourself with, that gets used a lot in mathematics, are the case where n equals 1, n equals 2, and n equals 3. When n equals 1, we just have the straight line y equals x. When n equals 2, we have the what's called the squaring function, whose graph is just a parabola. And then when n equals 3, we have what's called the cubing function. And remember I said the cubing function, right, snakes through the origin. Okay. And then on the next page, we learned about rational power functions. So the rational power function, the exponent, right, is just a fraction. And two of these that I recommend that you familiarize yourself with, because you'll see them a lot in math, especially those of you who have taken calculus, is the square root function, or x to the 1/2 power, and the cube root function, right, x to the 1/3 power. Okay. All right. And then we learned about even and odd functions yesterday, what an even function is, what an odd function is. I'm going to release this homework today. You'll get a lot of practice with this homework of testing a function for whether it's even or odd or not. And then start talking about transformations of functions at the end of the period. And we did talk about vertical shifts, right? The vertical shift is when you add a positive number to a function, right? It shifts the graph up that many units. When you subtract a positive number from a function, it shifts the graph down that many units. Okay. So in 3 and 4, we have what are called horizontal shifts. And the first one in 3, when you replace x and f of x with x plus a positive number, okay, that has the effect of shifting to the graph to the left that many units. So yesterday we were using the squaring function. We're talking about vertical shifts. We'll do the same thing with horizontal shifts. So here's the graph of y equals x squared, right, the squaring function. It's a parabola that goes through the origin. Okay. So if I replace x with x plus c, where c is a positive real number, so we got the graph of y equals x plus c squared. Okay. When we replace x with x plus c, and our graph is still a parabola, this parabola, but it's shifted to the left c units on the x-axis. Okay. And so this, since c is positive, okay, this is actually the number minus c on the x-axis. And so we have our parabola, but it's shifted to the, it's the same parabola as this one, but it's shifted to the left c units from the origin. And then similarly, number 4, we replace x and f of x with x minus c. That has the effect of shifting the parabola to the right c units. So here's c on the x-axis, right? It's a positive, c's our positive real number. And so the parabola gets shifted to the right c units when we replace x with x minus c. Replace x here with x minus c. It shifts the graph to the right that many units. Okay. That's what we mean by transformations. Okay. So in example 2, we're going to sketch the graph of a quadratic equation. Okay. So the basic graph that we start with in this is this guy over here, y equals x squared. Right? The basic graph that we're starting with, the basic equation is y equals x squared. And so when x down here gets replaced, right? So x down here is replaced with x minus 2. So then instead of x squared, we got x minus 2 squared. And so our parabola down here just gets shifted to the right 2 units. Right? This is the x-axis, this is the y-axis. And so this is the graph of y equals x minus 2 squared. Okay? We got it from the graph of y equals x squared just by shifting it to the right 2 units. In B, we're doing 2 transformations. Okay? We're replacing x down here with x plus 3. Right? So we have x plus 3 squared, but then we're subtracting 2 from the function. So we can do more than one transformation at once. When we replace x with x plus 3, it shifts the graph in what direction? Left. And how many units? 3, right? So we're going to shift our parabola down here, right? Left, 3 units. And then when we subtract 2, what direction does it go? Down. How many units? 2, right? So here's the origin. So to go left 3 units, it puts you at minus 3 on the x-axis. And then you got to go down 2 units. And that's minus 2 on the y-axis. Right? So the vertex of the parabola down here is at the origin. Now the vertex appears at the point minus 3, minus 2. Right? Because we shifted to the left 3 units and then down 2. And so that's the graph of this equation. And we got it from the graph of our basic parabola. Okay. Any questions on that? All right. So now we've done vertical and horizontal stretches. Let's talk about vertical stretches and vertical compressions. Okay. For any positive real number c, the shape of the graph y equals c times f of x. So we have our beginning function y equals f of x, and now we're going to multiply that function by a positive real number c. Okay. The shape of this shape of the graph of this function c times f of x is the same as the graph of f of x, but with the change in a vertical scale. Okay. The domain is the same for this new function, c times f of x, and it has the same x-intercepts. Okay. So down here, it says that if c is greater than 1, the graph gets stretched vertically. Okay. It gets poled vertically. Okay. And if c is between 0 and 1, the graph gets compressed. Okay. It gets flattened. So we'll demonstrate this in example 3. So we have the graph of a function y equals f of x. And now we're going to graph the function y equals 2 times f of x. Okay. So c is equal to 2 in this case, right? The c up here is equal to 2. Well, multiplying f of x by 2, right? 2 is greater than 1, so it's going to stretch this function vertically, and the x-intercepts don't go anywhere. They're the same after you stretch the function. But what's different is the y coordinates. The size of the y coordinates get doubled. Okay? Because remember, y coordinates and function values are the same. So if you double the function values, you end up doubling the y coordinates. Okay. So over here in our original graph, you'll notice that the point -4, -6 is on the graph. The x-intercept -3, 0 is on the graph. The point -2, 2 is on the graph. The graph passes through the origin, 0, 0. And then the point 1, -1 is on the graph. The x-intercept, 2, 0 is on the graph. And looks like the point 3, 4 is on the graph. So to get the corresponding points for the function y equals 2 times f of x, we just multiply each of those y coordinates by 2. Okay. Because remember, y coordinates and function values are the same thing. Okay. So going 1 by 1, 2 times -6 is -12. So the point 4 -12 is on the graph. 0 times 2 is 0. So the x-intercept -3, 0 hasn't moved. 2 times 2 is 4. So the point -2, 4 is on the graph. 0 times 0 is 0. So the graph still goes through the origin. -1 times 2 is -2. So the point 1 -2 is on the graph. I'm sorry. When you can't see, right, please say something. And then 0 times 2 is 0. So the x-intercept, 2 zeros, is still on the graph. And then 4 times 2 is 8. So 4 times 2 is 8. So the point 38 is on the graph. So let's plot the points. Well, -4, -12. -12 is way down here somewhere. Okay. -3, 0. There's that x-intercept. -2, 4 is up here. Okay. So notice that this point at -2, 2 is now up here at -2, 4 when we multiply the function f of x by 2. Then it goes through the origin. Then 1 -2 is down here. Right, so notice at this point here, 1 -1 is now down here at 1 -2. Then we got the x-intercept, 2, 0. And then we have the 0.38, which is a little bit off the graph, right? It's kind of like way up here. And so now we connect the dots with a smooth curve. And that's what the graph of y equals 2 times f of x looks like, right? It's been stretched vertically, okay? Horizontally, it's the same. It's been stretched vertically. Okay? Any questions on that? All right, in y equals 1/2 f of x, that is a compression, right? 1/2 is between 0 and 1. So this is a compression. So the graph is going to get flattened. And so we multiply the y coordinates over here all by 1/2 and then plot those points. So 1/2 of -6 is -3. 1/2 of 0 is still 0. 1/2 of 2 is 1. 1/2 of 0 is still 0. 1/2 of -1 is -1/2. 1/2 of 0 is still 0. And 1/2 of 4 is 2. And so we plot those points. So here's -4, -3. So you notice this point over here, it's now been moved up to here with the compression. Here's the x-intercept -3, 0. Here's the point -2, 1. So notice this point here has been brought down 1 unit. Okay. Here's the origin. Here's the point 1 -1/2. Here's the x-intercept 2, 0. And here's the point 3, 2. And now we connect the dots. And that graph looks something like that. That's the compression. Okay. You can see how it's gotten flattened, going from here to here. Okay. All right. Any questions on that? This section, there's no solving for x or anything like that. It's all conceptual in this section. Okay. All right. So now let's talk about reflections. Okay. And this is supposed to be a minus sign in front of f of x here. So you might want to make it a little bigger. Okay. So if we multiply f of x by -1, so remember that minus sign is the same as -1 times f of x. Okay. So if we multiply f of x on the right hand side by -1, okay, that creates a reflection of the graph up here, and it reflects it across the x-axis. So you can think of it as the top half and the bottom half flipping over, but the x-intercept, using the x-axis, the x-intercepts on the x-axis as pivot points. So that x-intercepts don't go anywhere. This thing just rotates using the x-intercepts as pivot points. Okay. Flips over the x-axis. Okay. So our graph here has the same points as a up above. So maybe I'll rewrite them. -4, -6, -3, 0, -2, 2, 0, 0, 1, -1, 2, 0, 3, 4. So what happens when we flip this thing over the x-axis is that the sign of the y-coordinates change. Okay, they go from negative to positive, positive to negative. Okay, so -4, -6 becomes a point -4 + 6. And again, up here above the grid, right, that should be y equals minus f of x. If you want to make that minus sign a little bit bigger. -3, 0 stays the same. -2, 2 becomes -2, -2. 0, 0 remains the same. 1, -1 becomes 1, 1. 2, 0 remains the same. And 3, 4 becomes 3, -4. And so now we plot those points. Here's -4, 6 up here. -3, 0 is right here. -2, -2 is here. Here's the origin. Here's the point 1, 1. Here's the intercept 2, 0. And then here's the point 3, -4. So when we connect the dots, that's our graph. And you can see, okay, that the graph of y equals minus f of x is this graph right here flipped over the x-axis. Okay? Instead of going down on the left, it's now going up. Okay? Instead of the hump being above the x-axis here, it's now below the x-axis. Okay? And so forth. Any questions on that? Okay. All right. Up here it says y equals f of minus x, right? When we replace x with minus x, that creates another kind of reflection, but now it's across the y-axis. So our graph here gets flipped across the y-axis using the y-intercept as a pivot point. Okay. So now we got to change the sign of all the x-coordinates over here. So -4, -6 becomes +4, -6. -3, 0 becomes +3, 0. And so when we flip this graph across the y-axis, this x-intercept gets moved over here. Because we're flipping it around the y-axis. -2, 2 becomes +2, 2. The origin doesn't change. 1, -1 becomes -1, -1. 2, 0 becomes -2, 0. And 3, 4 becomes -3, 4. And now we plot those points. So here's 4, -6. Here's 3, 0. Here's 2, 2. Here's the origin. Here's -1, -1. Here's -2, 0. And here's -3, 4. And now again we play connect the dots. With a smooth curve. can see our graph here, right? By replacing x with minus x, we took our graph over here and it flipped it over the y-axis, okay? Using the y-intercept as a pivot point, okay? Any questions on that? All right. So now that we've laid out all the definitions, so in these next three we have to write the equation that goes with the transformations that we're given. Okay. So give the equation for the function whose graph is a graph of f of x equals x to the 1/3, right? So you recognize this, should recognize this as the cube root function, right? Or x to the 1/3 is the cube root of x, okay? But we're going to use this version, right? X to the 1/3, okay? So to take this graph and shift it up 4 units, what do we do to the right-hand side of this equation? Pardon? Add 4, right? So the graph of y equals x to the 1/3 plus 4 is the graph of y equals x to the 1/3 shifted up 4 units. Okay. That's what we want. Now we want the equation for the graph of x to the 1/3 shifted right 3 units and reflected about the y-axis. Okay. Well, to shift it right 3 units, we replace x with x minus 3, right? To shift it right 3 units, replace x with x minus 3. And now to reflect it about the y-axis, we got to replace x with minus x. That's what we learned on the previous page. So we have y is equal to minus x minus 3 raised to the 1/3. Okay. So first we replace x with x minus 3 to shift it to the right 3 units. And then we replace x with minus x to reflect the graph across the y-axis. Okay. And C, we want the equation for the graph of f of x equals x to the 1/3 or y equals x to the 1/3 shifted left 1 unit and reflected about the x-axis. Okay. Well, to shift this graph to the left 1 unit, you got to replace x with x plus 1. So y is equal to x plus 1 to the 1/3. And now to reflect it across the about the x-axis, we multiply the right-hand side by minus 1, or a minus sign. So if y is equal to minus times x plus 1 to the 1/3 power. Remember that minus sign out front is the same as minus 1. Any questions on those transformations? Alright, in example 6, we're not only going to do the transformations, we're actually going to graph the transformation. Okay. Alright. So one thing in doing these transformations, it's usually wise, almost always, if not always, to do the vertical transformations last. Okay. Alright. So here we're going to sketch this graph starting with a basic function. Okay? And you notice that we have in parentheses here raised to the 2/3 power. So the basic function that we're going to start with is y equals x to the 2/3 power. You don't have to flip back, but we graphed this on page 1 right here, right? It's the middle graph, y equals x to the 2/3. So we're going to start with this graph, and then we're going to perform transformations on it to graph the equation that we're given. Okay? So we have this down below here, I'm going to graph y equals x to the 2/3 from page 1. Looks like this. And now we're going to perform a series of transformations on it to get the graph of this equation. Okay. So we start off with y equals x to the 2/3. And if I replace x here with x plus 2, that shifts the graph of x to the 2/3 left 2 units. And now, you notice the -1 out here in front of x plus 2 to the 2/3. So now if I multiply the right-hand side by -1, or a minus sign, that reflects the graph what's the wording they use? Across the x-axis, right? Reflect across x-axis. And now if I subtract 1 from the right-hand side, it shifts the graph down 1 unit. So when I take this graph, first I shift it to the left 2 units. So here's our beginning graph, right? Y equals x to the 2/3, right? So when I replace x with x plus 2, it shifts the graph to the left 2 units. so that the vertex is no longer at the origin, it's at -2. Right? So this is a graph of y equals x plus 2 to the 2/3. Now I multiply the right-hand side by -1. When I do that, it flips the graph over the x-axis. So here's -2. So this is the graph of y equals minus x plus 2 to the 2/3. Okay. Now lastly, we subtract 1 from the right-hand side, and that shifts the graph down 1 unit. And so lastly, you shift the graph down 1 unit. Here's -2. Here's -1. And so that's the graph of this equation. Okay? After those 3 transformations are performed on our starting equation. Okay. Any questions on that? All right, and the next one to the right, actually let's do C. That one's easier. Okay. So looking at the equation y equals the square root of 3 minus x, right? You should recognize that we're starting with the square root function. Y equals the square root of x. And so from page 1, we graph the square root function. It looks like this. Okay. And now we're going to perform a series of transformations on that so we can get the graph of y equals the square root of 3 minus x. So we start off with y equals square root of x. Now if I replace x with x plus 3, that shifts the graph to the left 3 units, right? Actually, I'm going to cut into the other graph. I'm going to do it down here. Start off y equals square root of x, and then replace x with x plus 3, which shifts the graph left 3 units. And now if I replace x with minus x, I have the square root of minus x plus 3, and when we replace x with minus x, it reflects across the y-axis. And you should recognize that the square root of minus x plus 3 is the same as the square root of 3 minus x, which is our equation up here. So we take the square root function, we shift it to the left 3 units. And so when we shift it to the left 3 units, right, this point here at the origin is now at x equals minus 3. And then we reflect it across the y-axis using this y-intercept as a pivot point. So this point here at -3 is now over here at +3. And then the graph goes to the left instead of to the right. It goes from here to the left through that point. So here is x equals 3. The graph looks like this after those two transformations are performed on the square root function, y equals square root of x. Okay. Any questions on that? Okay. B is a little bit challenging, so we'll do that one now. So you can see that the basic function is y equals x to the 3/2. Okay. And the graph of that, y equals x to the 3/2, is also from page 1, I believe. It's on page 1. Yeah, it looks something like that, right? Almost looks like the right half of the parabola. All right, so to find the graph of this equation, we got to perform a series of transformations on our original equation. Okay. Y equals x to 3/2. Well, if I replace x up here with x plus 1, you know that shifts the graph to the left 1 unit. Okay. This graph down here to the left 1. Okay. And then I'm going to replace x with minus x, which then takes the graph and flips it over the y-axis. Y is equal to minus x plus 1 to the 3/2 power. I replace x with minus x. And so that's the reflection across the y-axis. Okay. And then remember, minus x plus 1 is the same as 1 minus x up here. Okay. And then I'm going to add 2, which shifts the graph up vertically 2 units. So y is equal to 2 plus, and I'm going to rewrite minus x plus 1 as 1 minus x. And so now that shifts the graph up 2 units. Okay. So first I shift this graph to the left 1 unit, and then I flip it over the y-axis, and then I shift it up 2 units. Okay. So let's see what that looks like. So we start off with y equals x to the 3/2, right? And first transformation is to shift that graph to the left 1 unit. So this point at the origin gets shifted to x equals minus 1. So this is y equals x plus 1 to the 3/2. And now we got to reflect across the y-axis using this point on the y-axis as a pivot point. So this guy, right, so this point here at minus 1 comes over here to plus 1, and then the graph goes up to the left. crossing through that point right there. So this is the graph of y equals 1 minus x to the 3 halves. And now we shift this entire graph up 2 units to get the final graph. So here's x equals 1. Here's y equals 2. And so this point here is now going to be at the point 1, 2. And then it goes up and to the left. Okay. So that's what the graph of this equation looks like. And we got it from the graph of y equals x to the 3 halves. All right. So see if you can figure out D on your own before class tomorrow. Okay. We'll compare answers. How's it going?
Good, how you doing?
We thought we might take a quiz.
Oh, I'm sorry, I forgot. Why is he looking? I thought we were waiting for attendance.
So as usual, but it's only front page. So when you're done turning your quiz, then you're free to go. Boy, did you guys read that? Did you read that? One up there on the screen? You could do that.